Hello and welcome to your channel AWS Cloud Bytes. I'm your host Bhavesh Kumar. Today we're going to talk about AWS Transit Gateway, and this is going to be a full mesh connectivity. We'll have three VPCs where a transit gateway will allow the data to flow between these three VPCs. Let's look into the details of transit gateway setup that we're going to do in this lab. We're going to have three VPCs, VPC A, VPC B, VPC C, as shown in this picture. VPC A will have two subnets. One will be the public subnet, which is going to be attached to an internet gateway, and you'll have a private subnet. The public subnet is required just because I want to do an SSH. It is going to be kind of a jump host for me where I can do an SSH on the public EC2 instance using the public IP address that EC2 instance will have. And from that public subnet, in this case over here, I will jump to this private subnet, which doesn't have any kind of internet connectivity or even a NAT gateway to talk to internet. So the way this is going to work is once I jump to this machine from here, I will do an SSH to the private network. This private subnet will then have a connectivity between the two private subnets over here in VPC B and C. You have just a private subnets, no internet connectivity, no internet gateway, no public subnet. So they are all connected using this central piece over here, which is the transit gateway. And the transit gateway is connected to each VPC using a transit gateway attachment. So you'll have three transit gateway attachment. These attachments are going to be associated with a specific subnet. In this case, it is going to be attached to a private subnet here, a private subnet in this VPC A, and a private subnet in VPC C. So transit gateway will have its own route table, which is going to register propagated routes that are dynamically added by the learning from transit gateway attachment. As soon as we build this attachment, build these three attachments, and if we enable the dynamic propagation, the route table, the default route table of transit gateway will be populated, and you will see that the propagated routes are showing. The route type will be propagated rather than manually added. And following that, we're going to add a route in the VPCs so that anytime the route table of the private subnet in ABC 3 VPCs, anytime there is a request to go to a specific CIDR, which is like 10.1.0.0 or /8, which is any route that is requested for this particular CIDR or this particular CIDR, it should go to the transit gateway, which will know where to route it. So from VPC A, if the request is for 10.2.0. whatever the IP address of this EC2, then the route will be from transit gateway to this particular attachment. Okay, enough said about this. Let's see how we're going to implement. We're going to first create three VPCs, then we're going to create the transit gateway, and then three attachments will be added. Following that, the route propagation will be inside the default route table with the transit gateway, and then we're going to update the private subnet route tables in all three VPC to enable the ping from all three VPCs to each other. Okay guys, I have logged into the AWS console. I'm gonna search for VPC. You'll see a VPC under services, and by default you will see just a single VPC, which is provided by the AWS, and I will just name it as default VPC. So first step that we are going to do is we're going to create a VPC, VPC A, and the CIDR will be 10.0.0/16, and we'll create this VPC. We'll go back to the VPC again, and then create another VPC. This will be VPC B, and then this will be 10.1.0.0/16. We need to have VPCs that are not overlapping. So this one is VPC B. We have A, B, and now we're going to create a C. VPC C, and then this will be 10.2.0.0/16. Okay, so we got three VPCs now. For each VPC, we're going to create subnets. So let's go into the subnets, and these are all associated with the default one. We're going to create public and private subnet for VPC A, and this is, I would say, public subnet in any zone. I don't care. This is VPC CIDR block, and for this subnet I will do 10 dot, this is 10.0.1, this is, I'll just do 0.0/24. This is 256 IPs. Sorry guys, I forgot to record creation of subnet, but then this is the overall picture. The VPC-A, it has two subnets. One is under 10.0.0.0/24, and then the other subnet is at 1.0/24. And this is a private subnet. The one with 0.0 is the public subnet. Then I created a private subnet under VPC-B, which is 10.1.0.0/24. 256 IP addresses, available are 251. Similarly, in VPC-C, I created another subnet, which is 10.2.0/24. This is again 251 out of 256 available subnets IP in this private subnet. Now, if you look at it, there are no routes right now because there is nothing configured. These subnets are just created. So what we're going to do is we're going to create a internet gateway and attach it to VPC-A. And we need internet gateway just because we want to host EC2 in a public subnet as a jump box, so that I can do an SSH to the public subnet and then do a SSH to the private subnet, where we can look at the connectivity between VPC-A and VPC-B, VPC-A and C. And similarly, like, it will be a full mesh connectivity. So A can talk to B and B can talk to C without doing a number of peering, because the transit gateway is the one that is going to allow you the full mesh connectivity in this particular lab. Let me go to the internet gateway. I'll search internet gateway. It's easier to search rather than to scroll through. So what I'm going to do is I'm going to create an internet gateway. There's no internet gateway, so I will say VPC-A IGW, and this internet gateway has been created. There was already one that was attached to another VPC, but then let's attach to a VPC. In this case, we want this to be attached to the VPC-A. Now this one is attached to VPC-A. Now we have the internet gateway, and you can see VPC-A, B, and C. All of them have their main route tables. What we are going to do is we are going to attach internet gateway in this main route table on the VPC-A. So you can see this is VPC-A. I'm going to open this main route table and I will edit the routes. There is a local route, but I want to add another route to the internet, and this will go to the internet gateway, which we have the IGW over here, and then we'll save. So you can see there are two routes now. There is internet gateway and there is a local route. Now let's go to the route tables. We have two subnets, and if you look at the subnets, let's look at the subnets. So both the subnets are attached to the main route table. Let me open this route table in a new tab. Let it load. So this is the main route table attached, and this is attached to internet gateway, which means both public and private subnet, they can actually access internet, and they are public right now. So what we're going to do is we're going to create route tables. So we're going to create two route tables, actually three. So private route table VPC-A, and then we'll select VPC-A for that, create that route, and this is by default just the local route. I'm gonna create two more. So private route table VPC-B, and then this is for VPC-B. I'm gonna create the third one, create route table, private route table VPC-C, and this is for VPC-C. Well, for VPC-B and C, we didn't need it because there is no internet gateway, but still, I just created. So for the subnet, which is private over here in VPC-A, I need to change the route table. Right now, it is attached to a route table which is public in nature. So I'll take the private one, which is only local. So anything hosted, any EC2 instance hosted in VPC-A will not be able to interact to internet traffic because there is no NAT gateway and there is no association to internet gateway. Only the public subnet will be accessible by internet because it is connected to internet gateway, and EC2 hosted over here will be available for access publicly. I'm going to host EC2 instances in the public and private subnets on VPC-A, and then a couple of EC2 instances in VPC-B and C. Right now there are no instances running, so let me create an instance. Launch an instance here. I'll just say this is public EC2 VPC-A, and we'll just stick to the default AMIs. D2 micro. I need to get a new key pair. Okay, that key pair is done, and then this one is associated with the default VPC, which we don't want. We want this to be associated with VPC-A, auto assign public IP because this is jump host for us. So we'll create this, and this is going to be public SG VPC-A. I think that is fine. SSH 22 is there. Rest of the stuff looks good. I will launch this instance. Okay, going back to EC2 again. So we have, let me remove the filter. We have one EC2 that is launching right now, and I'm gonna go and create another EC2, and this will be private EC2 VPC-A, and I'm gonna create the same kind of instance. I'll use the, also let me change this. This should be VPC-A, and then this is private subnet. Okay guys, I just realized that I made a mistake while creating the previous EC2 instance, where I should have selected the public subnet where the internet gateway is available, and by default it just picked the private subnet. It was all selected, so I forgot to pick that up. But then I have to recreate the first instance. I tried to change it and it was taking more time, so I just recreated a new EC2 instance with the public subnet and the VPC. In this one we don't need to have the auto assign IP because this is going to be in the private subnet and it doesn't need a public IP. We are just going to work through the private IP. I'm going to select the same security group. The name says public, but then it is just a security group with port 22. You can look at the port 22. So it is giving you port 22, and I could do that. This particular source can be from the public subnet, but that's okay for this particular demonstration. This is all set, and this is D2 micro. It's private EC2 in VPC A. Let me create this one. So let me go and launch a few more. Like we have two of them. We have one public EC2 and one private EC2. Both of them are running. And one has the public IP, the other one doesn't have a public IP. If I select this one, you can see you just have the private IP address, no public IP address. So what I'm going to do is, this is going to be a jump host for me. I'm gonna log in using SSH to this particular machine using the public IP, and then from there I will SSH to this machine, and from there we'll test the connectivity. Right now there is no connectivity. Let me create two more instances, and these are all going to be private EC2 on this is VPCB, and it's going to be the same stuff. I'll have the same key pair, and let me change the network carefully this time. So you have VPCB. Keep in mind it is just using the existing, and this is private subnet only. There is no public subnet there. And we haven't even changed the route table because the route table is exactly same. So I'm just using the default group here, security group. Let me create this one. And while it is launching, let me create another EC2. And this one will be private VPC. This is EC2 and VPC-C. Now you have, we'll just use the same key, and I'm gonna use existing, but for VPC-C, we have the private subnet. We don't need a public IP. We gonna select an existing default subnet security group over here, launch it. So let's see how many instances are running right now. So this is the one that I terminated because there was a mistake at my end. But then you have two instances in VPC-A, one in VPC-B, and one in VPC-C. Once we have all these running, I will SSH to this particular IP, and then we'll see connectivity from there. Right now there is no connection between these VPC. There is no VPC peering or a transit gateway between them. Once we are done with that, we're going to create a new transit gateway and then create the VPC attachments. Okay, this is the picture of the architecture that we are trying to build. We have the VPC. So we have this VPC, VPC-A with a public subnet, private subnet, and two EC2 instances, and the CIDR available here. Then we have VPC-B, only private subnet and EC2. Then we have VPC-C with a private subnet and an EC2. And all three CIDRs are over here. There is no transit gateway attachment between them. There is no transit gateway. So basically there is no connectivity between these VPC. And we're gonna start with having a transit gateway, then creating three attachment and see how the routes are propagated and how the routes have to be modified over these VPCs so that VPC-B can talk to VPC-C and VPC-B can also talk to A, and similarly A can talk to B and C. Similarly C can talk to A and B, which is full mesh connectivity. Okay, all four EC2 instances are running. Now let's take the public address, or I can just click on the connect button over here for the public EC2, which is going to allow me to connect using the public IP address. This is without using a client of my own. I'm just using what AWS is providing as a client. And it is establishing a connection, and I am in. So you can look at the IP address. This is the private IP address of this instance. You can go back to the instance. This is the instance. Okay, let me just filter it to the running ones. So this is the instance that we have, and the private IP address is 10.0.0.194. And if you go to this one, you can see I am in 10.0.0.194. And I already copied the key.pem file that was downloaded while creating all these EC2 instances. So I'm going to use this to connect to the private IP address. And in order to connect, I have to do the SSH to the private IP address. So I'll just say SSH-I, and then I'll just refer to this PEM file. You have the EC2 user, which is the default user. And then I need the private IP address. Let's go to the private EC2, copy the private IP address, which is 10.0.1.132, and I'm going to paste over here. And you can see that my prompt is currently 10.0.1.132. Now, if I do a ping from here to any of the other private IPs, so this one is on VPC C with 10.2.0.214 IP. And if I do a ping, you will see I will not receive any response. So there is no response on this one. Similarly, let me do a ping on the next one, which is the private IP address of EC2 hosted in VPC B. And if I do it from here, let me add ping. You can see there is no response as of now. So as part of our initial step, we have created 3 VPCs and we have hosted 4 EC2 instances in these 3 VPCs. Now I have done an SSH on the public EC2 instance on VPC A, and from VPC A public instance, which is the jump host, I have done an SSH to the private EC2. From private EC2, I don't have any connectivity to VPC B and VPC C. As next step, we are going to create the transit gateway and the gateway attachments. Let's create a transit gateway. Let me search transit gateways. So if I go to transit gateway, I open that into a new tab. There are no transit gateways. I'll create TGW transit gateway, VPC A, B, C. You can give whatever name you want. So for DNS support, we are just keeping it on the ECMP, which is equal cost multipath. We'll just keep it checked. Is not required for this particular demo, but we are not changing any of these settings. So let me create a transit gateway. It is going to take some time. Let me pause the video. Okay, the transit gateway is now available. So you can see the transit gateway is here. Now I'm gonna create gateway attachments. So let me search for transit gateway attachments, which is here. I'm going to create 3 gateway attachments just to show you the picture again. So what we just created was this piece. Now I'm going to create 3 attachments, TGW attachment A, B, and C, these 3. And then we're going to put the configuration to enable the traffic flow between these 3 VPCs. So let's go there, create a gateway attachment, and I will say TGW attachment A, and this is the transit gateway that we have, and the type will be a VPC attachment. The VPC will be VPC A in this case, and we have to specify which subnet to connect. So we have a private subnet, we have a public subnet, and this is where we want the attachment to be connected. So in this case, we are selecting the private subnet, and we'll create the attachment. Now I'm going to create another TGW attachment VPC. I think I will just say B, and then this is again a transit gateway that we have, VPC attachment, DNS support, everything is enabled. I will say VPC B, In VPC, we just have one single subnet, which is private subnet. I'll create that. And then I'll create another attachment, TGW, attachment C. And this is going to be, again, VPC. And this is VPC C. VPC also has a single private subnet, and we'll attach it to that. So we are waiting for these to be up and running. And once they are done, we'll proceed further. I will pause the video. Okay, now we can see that all three attachments are available. You can always go in the VPC dashboard, and there is a Transit Gateway section if you don't want to search. So all these three attachments are now available. They are attached to the single Transit Gateway that we have, and they are all associated with a single route table, the Transit Gateway route table. Let's look at the Transit Gateway. Before we go there, we can see that they're associated with the three different VPCs, VPC A, B, and C. This is A, this is B, and this is C. Let's go to the Transit Gateway. And this was something that we already saw. Now let's look at the route table. If you look at the route table, this is default, and it is enabling propagation. You can see the default association and default route propagation. Now what will happen is, given these three attachments, if you look at the propagation, that is enabled. And if you look at the routes over here are, you can see the route type is propagated. And if I go to this and try to ping it again, you will see that even though the routes are there in the Transit Gateway with the Transit Gateway route table, it is still not allowed to ping. And the reason is, let me bring the picture over here. The reason is that we created this Transit Gateway, which allows route propagation. So anytime there is a new route discovered by the gateway attachment, it will propagate to all other attachments, which is like the route table of Transit Gateway will be updated. So all the new routes discovered by the attachment in each VPC will be propagated to the route table. So this works, but then this information is not available in VPC B, A, and C, because they know that for the local route, they will stay here. There is no public subnet here, but in this case, in VPC A, for the local route, they will stay within the VPC, which is like 10.0.0.0/16. They will stay within the local VPC, but anything that is requesting for 10.1.0, that route will be dropped. TGW is not propagating automatically to the VPC route tables. So we have to go and manually update these to say if anything that is, so this is a specific route /16. And if we add a route, say 10.0.0.0/8 in the VPC A, which is less specific route, it should go to the Transit Gateway attachment. And from Transit Gateway route table, it will automatically find which VPC to go. So that's what we have to change. Let's see what the change is. Now, in order to do the change, we'll go back to the instances, and I'll search for VPC. I'll just open VPC in a separate window. So you have all the VPC over here. Let it load. Then we go to the VPCs. So if I go to the VPC B, and if I go to the route tables, the private VPC, if you look at the routes, there are only 10.0.0/16 and local. So we'll have to add additional route. In this case, we're going to say 10.0.0.0/8, which is the superset of all the CIDR ranges in 3 VPCs. And for this one, we have to go to the Transit Gateway. I'll choose a Transit Gateway, and we have one Transit Gateway attachment over here. So I'm going to copy this, and I'll save this. Now that update has been done for A, let me go to the B, and in the B also we have to do the same edit. Go to the Transit Gateway and Transit Gateway attachment B and this. Save the changes, come back, go to the C. So we're going to edit the route in VPC C route table, Transit Gateway C. Now all three routes are updated, all the route tables. If you look at this, so any traffic that is going to this particular route will go to the local. If you are requesting 10.1.0.0, which is outside the range of this particular route, it will go to the Transit Gateway. And when it goes to the Transit Gateway, let's look at the Transit Gateway route table. When it goes to this Transit Gateway will understand that for a specific route like this, it has to go to the VPC, which is associated with this other attachment, like in this case, the B, VPC B. So if you look at the instance connect, if I ping 1.0, okay guys, last we saw that we had these attachments, all the instances are running, and we propagated all the route tables with the Transit Gateway. One thing we missed while creating the VPC was the ICMP protocol. If you look at the security group that we added all traffic, but we forgot to add the ICMP IPv4 protocol, which is required for the ping. And what I did was I added in the inbound. There is no need to add in the outbound. Outbound all is okay because it is stateless. This was added into the security groups of VPC A, B, and C. So this is A, B, and you will have another one in the C. So all three were added with the inbound security group. And if I do a ping now to 10.2.0.214, which is one of the EC2 instance. Let's look at the EC2 instances. So 10.2. This is 1.0.2.0.214. And if you look at it, I am pinging from 10.0.1.132, and I'm getting a response from this particular machine. And if you look at the private IP address, this is where I'm pinging from. Similarly, I can ping the VPC C. This one was VPC C, this one is VPC B. So 10.1.0.148. Let me break this and I can do a ping. Let me do a clear first. So I can do a ping on this one. I forgot the space. And you can see that I'm getting a response from there also, which means all the traffic is going through all these Transit Gateway attachments. The routes are allowing it to go from, look at the route table, because the request is going to 10.1 or 10.2. It is going through the Transit Gateway, and the Transit Gateway goes through its own route table, which is here. So given this route table, you can see when the routes are coming from either of the VPC, you can see the association. So these attachments are bringing all that information to this Transit Gateway route table, and given that it is CIDR 10.1.0 range, it will go to whatever the VPC this is. This is VPC B, and similarly this will be the VPC C. So from here, anytime you see a request to 1 or 2, 10.1 or 10.2, they will go through the Transit Gateway attachments and will be routed by the Transit Gateway route table. That's all I have for this particular lab. This is a full mesh traffic, but in some cases you want to have a restricted traffic where you don't want VPC A to talk to VPC B. but in some cases you want that VPC A can talk to VPC B only, and VPC B can talk to VPC A and C. So that's where you have to go and create another route table for each attachment. And so for given attachment, suppose the route is coming from VPC B to VPC A. If there is a route, that will be taken, otherwise the route will be dropped. So for that particular lab, we'll do another session where we're going to create same infrastructure, but we'll have a different kind of a route table. For now, let's call it a day for this particular lab. Thank you so much. Thank you. This is the end of the episode. Thank you for watching. If you like the video, please like, share, subscribe, and press the notification bell icon for future updates. This is your host, Bhavesh Kumar, signing off. Thank you.